in Cape Canaveral, and I think I'm sitting here with probably one of the happiest people in the room, the NASA Orion Program Manager, Mark Geyer. Mark, I guess this is a pretty big deal, right? Feels good to see Orion in space.
Very exciting. Very. The launch itself was, it was just a blast to see how well the rocket did. It was exciting to see as it went up into space. Again, being near a launch, being near a rocket that big, you just kind of feel it. So I was fortunate to be able to go outside and watch it. So it was an awesome job by the Delta IV team. And now they've put us in a great orbit, perfect orbit where we wanted to be. And so the upper stage has finished its first burn, and in about an hour and a half we'll do the next burn.
Okay, and I guess we've already passed a couple of big milestones for Orion too.
Yeah, for us. So all the systems we're on already. We've linked up with the satellites now in TDRS, but we had a couple of really key test objectives very early in the flight. Within 6 minutes, we jettisoned the service module fairings, which are there really to reduce mass for the rest of Orion. The fairings help carry load on the way up, and then we dump them. But it's a critical event. These pyrotechnic bolts and seams have to actually work correctly, and it looks like they were flawless. We had some great video of that. And then the launch abort system on the top. It's there to keep the crew safe when we have crew on board, but in this case we practiced the part where we need to get the LAS off, assuming everything went well, and it came off great, and we'll get some video of that later. So both of those were huge for us to succeed, and they were key events, which is why they were on the test, and they went great. So.
Sure, yeah. Well, certainly not the end of the milestones, though. What's coming up in the near term?
So we still have a bunch to go. So now the next big piece will be the upper stage will burn again in about an hour and a half, and that's when it really puts us in this very high orbit, the 3,600 miles. That's a big part of the mission, and of course it worked great first part, so it should do that again. And then for us, when that's over, we'll separate from the upper stage, and Orion will be totally on its own control, and we'll do navigation and guidance, bring it into the atmosphere. Of course, the heat shield then is doing its job. The propulsion system's keeping us steered in the right way. The computers are making sure we're pointed correctly. And then the parachutes will do their job. So we have a lot to go. We'll be kind of on the ride for a little bit here, but then we'll have a lot of excitement toward the end.
Okay. Well, I know we can't really relax yet, but we've seen some video from Orion. I think, went out and saw the launch itself. You've been working on this for a long time. What does it feel like to see Orion now in space?
Well, it's exciting because you have these ideas of what you'd like to do, and then you pull a team together that has the same passion to pull it together, and then you have to take those dreams and actually put it into reality and make hardware out of it. Now it's actually doing the job that it was designed to do. We still have a long way to go for this mission, but at the beginning everything is working great, and so we're very proud of the team and looking forward to the rest of the day.
Yeah. All right. Well, thank you so much for taking some time out.
Thanks very much, Brandy. Back here in Mission Control, the flight operations team watching carefully as Orion is put through its paces on the first orbit of its lifetime. Now 56.5 minutes into the flight, Orion in the upper stage of the Delta IV rocket, traveling at an altitude of 545 by 120 statute miles, approaching the west coast of Australia. There will be a acquisition of signal through the Dongara, Western Australia tracking station to augment the tracking and data relay satellite system a short time from now. Orion's thrusters have been thermally primed. There are 2 strings of thrusters, 6 thrusters to each string. They are being activated and checked out in terms of their thermal conditioning in preparation for Orion's high-speed entry a bit later this morning. The refiring, the reignition of the upper stage of the Delta IV rocket to enable Orion to break out of low Earth orbit is just under 58 minutes from now. That will be a 4-minute, 40-second burn of the second stage engine on the Delta IV to enable Orion to climb to an altitude, a peak altitude of 3,630 miles away from Earth and begin essentially a highly elliptical second lap of the Earth that will culminate with its entry interface and its high-speed return to Earth for a parachute-assisted splashdown in the Pacific, some 600 statute miles west of Baja, California. With liftoff on time today, right on the dot at 6:05 a.m. Central Time, we are expecting splashdown to occur somewhere in the neighborhood of about 10:28 Central Time, 11:28 a.m. Eastern Time. That will be 8:28 a.m. out in the Pacific Ocean, and of course we'll be refining that time as we get closer to the point of Orion's entry back to Earth. Also, the guidance and the global positioning system hardware on Orion will be targeting a specific splashdown target that will be computed by the flight dynamics officer in mission control, and we'll be reporting that intended splashdown point to you a short time from now after we break out of low Earth orbit, check out Orion's systems as it goes through the Van Allen radiation belt. In preparation for the passage through the Van Allen radiation belt for the first of two transits to test out the shielding on Orion and the effect of radiation on its computers and its other avionics systems, we are in the process of powering down the 3 flight test cameras. Those have now been powered down and will remain powered down for the next hour of the flight to enable the instrumentation and communications officer here in Mission Control to dump all of the video that was recorded during the ascent phase, including the launch abort system jettison that occurred at about the 6-minute 19-second mark into the flight, just seconds after the service module fairing panels were separated. Those were the first 2 major milestones for the Orion program. Both of those occurred by the book, right as predicted and right on time, and of course the data will be processed post-splashdown by Lockheed Martin and the Orion program as they pore over the data from this initial test flight. So everything continuing to go well. Countdown clocks here already ticking backward towards splashdown time, some 3 hours, 25 minutes from now. We'll be back shortly with another update on activities relative to Orion. But for now, we'll go back to Brandy Dean at Hangar AE at the Cape Canaveral Air Force Station.
Thanks, Rob. So no astronauts are on board Orion today, but of course we hope to put them on board in the future. And to talk a little bit with us about that, we have astronaut Rex Walheim, who was one of the crew members on the last shuttle flight, STS-135, yes, and is now the chief of the exploration branch of the astronaut office, right?
Yes, that's correct.
All right, tell us a little bit about what that means. What is your role in the astronaut office?
Okay, well, I'm the astronaut representative to the Orion program, so I serve on Mark Geyer, the program manager's team, and we evaluate the development of the project to make sure all things are being designed to the ways that we think are important, and watch over the safety, and then pay special attention to the crew interfaces, the displays and the controls, and the ways we interact with the vehicle.
Okay, and you also are working directly with Orion, kind of giving the astronaut perspective on.
You bet.
So what have you been seeing so far? What have you? What's important to you as an astronaut?
Right. Well, one of the things we want to really take a close look at are the displays, and so we've actually started getting into the development process. So in the astronaut office, we have what's called the Rapid Prototyping Lab, where we can develop some displays and working with our Lockheed counterparts. And we've been able to code them up and test them out, and then fix them from what we found in the testing. And we're doing this iteration. It's going really, really well. And so when we're ready to have humans on board Orion, we're going to have some great displays built up.
I think you've been inside the mock-up of Orion, testing out those displays yourself and some simulations.
Yes.
What have you found? How do they?
It's working great. It works great because it's it's another jump from where we were with the shuttle program. So we've got great interface where we can basically interact with the displays just using our hands on the throttle and the cursor on the control stick and cursor control device, so we can take all the actions we need, which is important when you're in a high vibration environment to be able to control the vehicle.
That makes sense.
Yep.
So I guess you probably got to see Orion lift off today.
Yes, I did. It was just magnificent. A dawn launch at the beginning of a new era in human spaceflight. It's just a spectacular day.
I agree.
Orion is flying.
All right. Well, speaking of that, so would you be willing to fly on Orion?
I would love to fly on Orion. I mean, as exciting as it is to go to low Earth orbit, to go to the space station, there's incredible things we're learning there. And the ISS is a U.S. national laboratory. It's our proving ground here, and then we're going to go even farther. And it just excites the imagination to think of going to the lunar vicinity, past the moon, to an asteroid, or to Mars one day.
What of those is most exciting to you?
I think the ultimate destination we all have kind of a consensus on is Mars. Everybody wants to go to Mars, and it's so important to go there and to figure out what happened to Mars and to establish our presence on another planet, so we become a multiplanetary species. And that's very important. You know, Mars may have once have had an environment very similar to ours. So what happened to it? What are the things you can learn from that? And then how can you apply those lessons back here on Earth?
Yeah. Well, let me ask you one more question. Having been on the last flight of the space shuttle, and now having been here and witnessed the first flight of our next human spacecraft, what does that feel like? What can you give us some perspective on that?
Sure. You know, on the last space shuttle flight, it was tremendously exciting, and everybody was happy to be there, and it was wonderful to see. But there was, with that excitement, it was tinged a little bit with melancholy, to be honest, because it was the last flight. And so it transitioned into this period where we were waiting for Orion to start coming online, and now we've turned the corner and Orion is flying, and that's a really exciting time. And so now you have that excitement back here at the Kennedy Space Center, and it's tinged with even more excitement with what's coming down the road.
Yeah, so we've got another flight coming up, and I guess a few years now on board the Space Launch System. I'm guessing
right.
that's also something you're looking forward to.
Absolutely, the Space Launch System. So this was the first tail number of the Orion fleet, and it gets even better from here, which is going to be amazing. So the next tail number, the next vehicle, serial number 002, is going to be unique for the ride that it's going up in space on. That's the Space Launch System. An incredible rocket. This magnificent rocket, when it rolls out of the VAB, you're going to look at it and it's going to take your breath away. It's just that spectacular, even before it flies. And when it flies, everybody's going to know about it. And then just after that, that's EM2. That's our first human mission. We have a crew on board. And that's going to be tremendously exciting, too. So a lot of great things ahead.
All right. Well, thank you at the cockpit of Orion at Johnson Space Center that we've been working on now. And now we have with us the Lockheed Martin program manager for Orion. And he's going to tell us a little bit about some of the building that Lockheed has been doing for Orion since they are the prime contractor. Thank you so much for joining us, Mike Haas.
No problem, Brandy.
All right. So why don't we start with just kind of explaining what the Lockheed Martin role is in Orion.
So Lockheed's role is as the prime contractor, NASA's industry partner in Orion. So we do the design, development, production, assembly, test, and integration of Orion, the whole life cycle.
Yeah, and I guess that seems to have gone well since we launched it today into space.
It launched well. The spacecraft is doing well. All of the systems are operating pretty much the way we expected them to, and that's a real positive. The critical separation events in the early part of the mission all went well. The fairing panels we watched come off, which was terrific to see. The launch abort system jettison worked and covered the capsule, and then we got full data, so those are all really positive steps.
Well, so I guess Lockheed and NASA together have been working on Orion for a long time. How's that partnership gone, and are you happy with what you ended up with?
I think the partnership has gone very well, actually. It's we have a good team. We both have distributed teams across the country. On the Lockheed side, we have our Houston program management team. We have much of our engineering support in the Denver facility. We build the primary structure in MAF, and we do everything else in Michoud Assembly Facility. We do everything else here at the Kennedy Space Center.
Yeah.
And NASA also has support from many different centers, as you well know, and the ability of the teams to work together in that distributed way, I think, has been very positive.
Right. So I guess that gives us a good lessons learned even already for the next one that building has already started on.
Well, and I've said that through the course of this week, is that we've talked a lot about this being a flight test of the spacecraft, but it's also a flight test of our whole partnership and organization. We've done some things uniquely for the test in that NASA actually tasked Lockheed to really be the integrator of the flight test, so that we actually purchased the Delta IV from United Launch Alliance.
Okay.
We did the integration with ULA, and we chair the mission management team here in Hangar A&E at the Cape. So that's a different role traditionally than what the prime contractor would do. So it's been interesting to be able to do things a little bit differently.
Yeah, well, it seems like it's worked out really well. So, so far, everything is going well in today's flight, right?
So far, everything is going well.
Okay. Well,
like I said, the jettison of the panels and the launch abort system were very important to us. Right now, the team is actually from the Mission Control Center in Houston, the NASA team that is actually supporting us in this test flight. is downloading the first of several data files to get higher level engineering data from Orion. Later on in the flight, at just under 2 hours, the second stage of the Delta IV burns again, and that's really the critical burn. That's what gives us the high apogee altitude, and it also sets us up for reentry. So we know what our true reentry profile is going to be once we get through that burn. And then as we approach reentry, we separate from the, well, just after that burn, we separate from the Delta IV upper stage, which is also the service module for this flight. So that's when the capsule itself, the crew module, is separate and flying on her own, so to speak. And then as we re-enter, we have the separation of the forward bay cover, which protects all the parachutes, and do all of the re-entry on the parachutes like we've done in various tests, but we do it in the real space environment.
All right. Well, so it's a lot to look forward to in the next few hours. All right.
And a lot of data to capture and review and continue to see how Orion is flying.
Well, we'll stick with you and watch as everything unfolds.
Okay, great.
We're now an hour and 11 minutes into today's 4.5-hour flight, and we're going to go back now to Johnson Space Center and Rob Navius, who's standing by there to give us an update from Mission Control Houston. Rob?
Thanks very much, Brandy. Back here in Mission Control in the Orion Flight Control Room. This is the Blue Flight Control Room, which was the initial room at which International Space Station operations was inaugurated back in 1998. The ISS was controlled from here all the way through 2006. The ISS, of course, now controlled from a separate flight control room since then, as those teams of flight controllers watch over the 6 crew members on board the International Outpost 24 hours a day. But the focus of attention today is in this room where Mike Serafin, the lead flight director, and his team of flight controllers have been on console since early this morning and now are carefully watching over all of the systems of Orion as we pass the 1 hour 13-minute mark into the mission. Orion is currently orbiting over the Pacific Ocean, moving from southwest to northeast in an orbit inclined 28.45 degrees to either side of the equator, orbiting at an altitude of 546 by 124 statute miles. Countdown clocks here in Mission Control are ticking backward toward the reignition, the second burn of the upper stage of the Delta IV rocket that is scheduled 41.5 minutes from now. That will be about a 4.5-minute burn. As we mentioned earlier, it will enable Orion to break out of low Earth orbit and head to a point 3,630 or so statute miles above the Earth toward peak altitude, testing out its systems as it passes for the first of 2 transits through the Van Allen radiation belt out to deep space, testing all of the systems that are relevant for this first flight test of America's newest spacecraft. It also puts Orion at the particular altitude that the Orion program needed in order to test its high-speed reentry back into the Earth's atmosphere, reentry that will see Orion traveling at some 20,000 miles an hour, about 84% of the velocity of a return from the moon, which of course will be exercised on Orion's next flight, exploration mission number 1, several years from now. But for now, that first flight test sets Orion up today for its high-speed reentry back into the Earth's atmosphere. It will be a fascinating last hour and a half of this flight. About 1 hour before splashdown, Orion will separate from the upper stage of the Delta IV rocket. Its thrusters and guidance systems will be exercised as it barrels through the Earth's atmosphere, building temperatures around its huge heat shield to about 4,000 degrees Fahrenheit as it makes its way back into the Earth's atmosphere. A series of 11 parachutes will be deployed in sequential fashion. The final trio of parachutes, the main chutes, will be deployed and will reef in a rather sequential fashion to quickly decelerate Orion from a speed of 20,000 miles an hour to some 20 miles an hour at splashdown time in just 11 minutes. A very dramatic return to Earth lying ahead for the Orion spacecraft, with splashdown now scheduled 3 hours, 9 minutes from now. at 10:29 a.m. Central Time. It'll be 8:29 a.m. out in the Pacific at the splashdown point, about 600 statute miles west of Baja California. At this time, there are video files, packets of files that are being downlinked that have been utilized from the flight test cameras and other structural cameras on board the Orion and the Delta IV upper stage, the service module, which is a test article, if you will, a mass simulator article for this first test flight. All of the cameras that recorded video of all of the critical events during the ascent phase for Orion, those files are being dumped to the ground. They'll be processed as quickly as possible. We hope to have some of that video for replay for you at the appropriate time, hopefully in about perhaps an hour and 15 minutes or so from now, maybe sooner. We'll keep you posted on that. Here in the flight control room, this team of flight controllers who have been training for this mission for several years, it is comprised of a team of legacy shuttle and space station flight controllers who have had their sights set on this very historic day for some time now, and they are moving about their business in business-like fashion, going through all of the checklists, monitoring their systems as we approach the point where Orion's major systems will be tested. Those first two milestones that we mentioned earlier, the jettisoning of the service module fairing panels and the launch abort system that occurred just after the 6-minute mark into the flight, those were the first two critical Orion program milestones. That now to be followed up as Orion begins to flex its muscles, heading out into deep space and preparing itself for its high-speed reentry, the true trial by fire that you've seen in that 7-minute video that we've been broadcasting on NASA TV for the past several weeks. Also, out in the Pacific Ocean, heading towards the splashdown zone, is an unpiloted airborne vehicle called the Icana. It was dispatched earlier this morning from the Armstrong Flight Research Center at Edwards, California, near Edwards Air Force Base. The Icana, this is a view from the Icana as it makes its way out in the Pacific toward the splashdown zone, so that if clouds permit, we should be able to get some view, hopefully, of Orion descending under its three main chutes prior to splashdown. We'll keep our fingers crossed to see if that video will be provided, and it's all weather dependent at this point. Icana is expected to be at the right place at the right time. Now it's all up to Mother Nature. The Spaceflight Meteorology Group a short time ago briefed lead flight director Mike Serafin on weather conditions out in the splashdown zone. Winds are very light, out of 030 degrees at about 11 knots. The wave heights are within limits. Everything is green as far as the weather constraints for splashdown and the ultimate recovery of Orion by the combined NASA U.S. Navy recovery team that will be led off of the USS Anchorage and the U.S. naval ship Salvor that are on station in the splashdown zone. So again, everything continuing to go very well as we approach the point about 36 minutes from now where Orion is going to be elevated into its second and final orbit, a highly elliptical orbit that will enable it to move away from low Earth orbit, the first time a human-rated spacecraft will have broken out of low Earth orbit since Apollo 17, 42 years ago. Video from one of the three flight test cameras in Orion's crew cabin, if you will, as Orion passes out over the Gulf of Mexico, approaching the west coast of Florida. We are now 9.5 minutes away from the upper stage burn number 2. Everything is in great shape on board Orion. There are no systems issues being worked by the flight control team here in Houston, and that sets us up for an excellent opportunity for all of the activity that will take place in the final hour and a half of this mission, all of the critical activity that will lead to Orion's return to Earth and a splashdown some 600 miles west of Baja California. We'll be keeping you posted on all of that as we go along. One of the Orion program milestones that has just been achieved was the dumping of all of the video in file form to the ground that is currently being processed, that included all of the signature shots for engineering data acquisition and also for our use here on NASA television, hopefully in the next hour to an hour and a half, of all of the critical milestone activities that took place in the ascent phase of the mission, including the jettisoning of the launch abort system that occurred just seconds after the 3 fairing panels around the service module had been jettisoned, the first pair of program milestones for the Orion program following Orion's launch atop the Delta IV rocket at 6:05 a.m. Central, 7:05 a.m. Eastern Time.
This is Delta Flight Commentary at 1 hour, 53 minutes, 21 seconds into the flight. Now 2 minutes remain until the start of the second burn of the second stage. This is Delta Flight Commentary at 1 hour, 53 minutes, 51 seconds of the flight, less than a minute and a half before the second burn of the second stage. This is Delta Flight Commentary at 1 hour, 54 minutes, 25 seconds. Less than 1 minute remains until the start of the second burn. This is Delta Flight Commentary at 1 hour, 55 minutes into the flight. Standing by for our second burn about 15 seconds from now. And we have igniter spark. And we have ignition. Ignition on the second stage. Second stage chamber pressure is beginning to rise. Good chamber pressure in the second stage. This second burn of the second stage is to last 4 minutes, 42 seconds. Chamber pressure is stable. Engine control is good. 1 minute, 55 seconds. Correction, 1 hour, 55 minutes, 53 seconds into the flight. About 4 minutes remaining in the burn. Continuing to look good. Chamber pressure's holding right where we want them to be. Good engine control. About 3 minutes, 45 seconds remaining in the burn. Still looking good. Chamber pressure is holding. Good engine control. Very stable burn. Velocity increasing to 27,000 feet per second. One hour, 57 minutes, 10 seconds into the flight. Engine control continues to look good. Chamber pressure continuing to look good. Good control. 1 hour, 57 minutes, 30 seconds in. About 2.5 minutes remain on the burn. Velocity now passing 27,538 feet per second. 2 minutes remaining on the burn. Chamber pressures continuing to hold right where we want them to be. Good engine control in the second stage. Velocity now increasing to 27,723 feet per second. Chamber pressures continuing to hold right where we want them to be. Good engine control. Velocity increasing to 27,956 feet per second. Less than 1 minute remains in the burn. Apogee increasing to 2,215 nautical miles. All continuing to go well. Chamber pressure continues to hold. Good burn, very stable. Very good engine control. About 20 seconds remaining in the burn. Apogee now increasing to 2,590 nautical miles. Standing by for SECO 2. And we have SECO. Beam is locked. The burn is complete. Recovering from SECO. Burn looks stable.
And back here in Mission Control in Houston, the Flight Dynamics Officer, Mark McDonnell, reporting to Flight Director Mike Serafin that we had a perfect second stage restart burn that lasted 4 minutes and 40 seconds in duration. The burn was initiated at right on time, just off the northern coast of South America, north of Guyana. And now Orion is beginning to climb away from Earth, heading for a peak altitude that will result in it arriving at about 3,630 miles away from the planet at its peak altitude opportunity, just about an hour from now. It is at that point that it will begin to complete its furthest transit away from the Earth and make all of the preparations essential for its high-speed return back to Earth and a splashdown under 3 main parachutes in the Pacific, some 600 miles west of Baja California. The current altitude of Orion atop the second stage of the Delta IV rocket is now beginning to climb away from Earth as Orion passes just south of the equator, moving from northwest to southeast at an altitude now of some 3,000 miles above the Earth, and again will pass through the Van Allen radiation belt a short time from now. Its flight test cameras are going to be powered down for this first transit of 2 planned for passing through the radiation belts of the Van Allen radiation region. Those flight test cameras will be powered down just a couple of minutes from now, and then it will be a 15-minute transit through the Van Allen radiation belt to test the shielding on the spacecraft and the effect of that radiation on its avionics. So we'll be back here at Mission Control a short time from now. Everything going perfectly on the maiden flight of Orion at a mission elapsed time of 2 hours and 3 minutes. Let's go back to Brandy Dean now at Hangar AE at the Cape Canaveral Air Force Station in Florida.
Thanks, Rob. And we're back now in the Mission Director Center in Florida, and I have with me here Bobby Gail Swan, who is the the project manager for RadWorks, Advanced Radiation Technologies. As Rob mentioned, with that engine burn, we're going to be moving higher and into the radiation belts that surround the Earth, Van Allen belts, and Bobby is going to tell us a little bit about why that's interesting to Orion. Thanks so much for joining us.
Thank you, Brandy. One of the reasons why it's exciting is because as we go through the Van Allen belts, we have on board EFT-1, the battery-operated independent radiation detector. It's a device that we've developed that will monitor and detect radiation. And why we want to monitor the radiation outside the belts is because as we go outside the geomagnetic fields and the protection that it gives us from radiation, we're going to be seeing a greater exposure. And so we want to capture that data. And
okay.
Once we get it, what we'll do is when we splash down, we'll go pick up the bird. And
the bird is, you gave the acronym. But,
I'm sorry.
No, you said it. Battery-operated
independent radiation detector,
okay.
the bird. And so we had a contest, and so thanks to the kids at the Clear Creek Independent School District, they gave us names to choose, and
very nice.
That was bird. And so when we pick up bird, we will take the data that we recorded, the radiation measurements, and we will couple it with the mission telemetry, and then we'll be able to say where and how much radiation we encountered in this journey.
Okay, so why are we worried about radiation? What can it do?
Because one of the things is we're worried about. We would like to have these measurements to better understand the exposure that the crew members will get to radiation.
Okay.
And so that's the main thing, is we want to be able to better define and understand this environment so that we know what we can do to try to mitigate the radiation from harming
sure.
the crew.
Sure, and I think you're also testing the same way on International Space Station, right?
Yes, we actually, the sensor that is making up the bird instrument, we've developed it with our partnership with the University of Houston, and they have access to this sensor, this new technology that was developed out of CERN. Okay. The Super Collider folks. And so we actually have packaged that in a thumb drive and have 6 of the active radiation monitors deployed on space station right now, detecting radiation. So we were able to test out the technology there, and now we have it packaged as a self-contained instrument that's flying on EFT-1, and then we are also working on a version that we will fly with EM-1 and EM-2. So we're really excited for this technology.
Well, I guess, the International Space Station, we know a lot about the radiation environment there, but it's very different than what we're experiencing here, right?
Yeah, absolutely. We're seeing we should see a greater amount of radiation as we go through the belts.
And that's just because we're getting farther away from Earth?
Absolutely.
All right.
That's the name of the game.
I think in the future we'll go even farther, and there's some other concerns. And I know there's a challenge going on right now that people can get involved in, right?
Yes. As you go outside the belts and stuff, you're going to encounter galactic cosmic rays. And so our instrument, the technology that we have will detect and monitor the galactic cosmic rays, but we're looking for ways to mitigate the exposure. And so in order to do that, we have a challenge, an incentive challenge out there, and we are looking for folks to help us mitigate the effects of galactic cosmic rays.
So if people have ideas, they should go online at nasa.gov, right? And just do a search for Galactic Cosmic Rays Challenge. And you'll
help
be able
us
to
out.
figure
We're
out
looking
how
for some
to
solvers.
get involved with that. We'd
Looking
love
for
to have
some
ideas.
solvers.
All right, so you've been working on this for a while. I know it must
Couple
feel
years.
good to
Oh,
see it
is.
fly.
It is, and it's like I may be here representing the team, but it is a team effort, and I just want to say congratulations to the entire RadWorks team, and especially those that work the bird element at Johnson Space Center in the Engineering Directorate, Human Health and Performance, our partnerships with the University of Houston, and of course all those fine folks at CERN that helped us get there.
Okay. Well, thank you so much for joining us, and we're going to go
Thank you.
back now to Rob and Mission Control Houston.
Thank you.
Thanks, Brandy. Here in the flight control room, everything is going swimmingly as Mike Seraphin and his team of flight controllers continue to watch over all of the data from Orion, which is functioning to near perfection at this point, 2 hours and 8 minutes into its flight since its launch atop the Delta IV Heavy rocket from the Cape Canaveral Air Force Station. As you can see, Orion is currently climbing away from low Earth orbit, currently at an altitude of 780 miles above the Earth, heading for an apogee of some 3,630 miles away from the Earth. This grainy view out of one of the windows through the flight test cameras on Orion. Those flight test cameras are going to be powered down just a few minutes from now as Orion passes through the Van Allen radiation belt for the first of two such transits. This will be about 15 minutes going through the highest peak moment of radiation for the spacecraft as its shielding, its avionics, its computers are exposed for the first time to the harsh effects of radiation to see how well Orion can withstand all of that. That will be critical, of course, to deep space and interplanetary travel for this spacecraft in the future. Meanwhile, splashdown preparations are underway out on the Pacific Ocean, with splashdown expected 2 hours and 15 minutes from now. The unpiloted airborne vehicle, the Icana, was dispatched very early this morning from the Armstrong Flight Research Center at Edwards, California. It is en route to the splashdown zone, which is expected to be about 600 miles to the west of Baja, California. Again, the flight dynamics officer will be getting us more precise data from the guidance systems on board Orion and its global positioning system hardware that will be kicked into action, particularly at the point that we begin the return trip back to Earth following the arrival at peak altitude 3 hours into the mission at 9:05 a.m. Central Time.